So first topic for the solid figures, I have polyhedron. So a polyhedron is a solid figure bounded by many plane surfaces or faces. So the flat surfaces is called faces. A straight line bounding a face is called an edge. A point at the end of an edge is called a vertex. And if the faces are all congruent regular polygons, equal polygons, no? The polyhedron is regular, otherwise it is irregular. Okay. So I have here an example of a regular polyhedron. No? So as you can see, all the faces here are equal polygons. So equal, in this case, equal pentagons. No? So this is what we call a regular polygon. Whereas here, a figure in which the faces are not equal polygons, so we call it a regular polyhedron. Okay? So, in a polyhedron, we call this a vertex. Huh? So, a vertex is the intersection between two edges. So, this we call this an edge. Edge, and then we have the intersection, the vertex. We call it a face. So we have here the polyhedron. Okay, so we have here the names of regular polyhedrons. So there are regular polyhedrons in which we have special names on them. So number one, we have a tetrahedron. So a tetrahedron is a polyhedron with 4 equal faces. And each face of a tetrahedron is an equilateral triangle. It has 6 edges and 4 vertices. So I will draw it here. Okay. So this solid is called a tetrahedron and each face is an equilateral triangle. There are 4 faces. That is why we call it tetrahedron. Tetra meaning 4. So 4 equal faces. So notice that we have here one equilateral triangle, another one triangle. So we have 2 equilateral triangles here facing to us. Then one equilateral triangle is at the back and one is at the bottom, at the base. Can you imagine it? Okay, so again, we have here 2 triangles facing to us. 1, 2. Then third at the back. Then fourth, that is at the bottom or at the base. So if we call each edge, the measure of each edge as A, then we have already the derived formula for the volume and surface area. The volume is given square root of 2 over 12 a cube. And the area is equal to square root of 3 a squared. By the way, for the area of the tetrahedron, we can also compute it using the area of the equilateral triangle. For equilateral triangle, we know sides and the included angle is 60. So just compute the area of one triangle and then multiply it by 4 because we have 4 equilateral triangles for its face or the faces. So area equal to square root of 3 a squared. Okay, then the second we have A is the length of the edge. Okay, so the second we have hexahedron or the cube. So a hexahedron is a polyhedron with 6 equal faces, and each face is a hexahedron of a hexahedron is a square. It has 12 edges and 8 vertices. So we have here. So again, hexahedron is simply a cube. So we have here 6 faces which are all square. So 1, 2, 3 on top, 4 at the bottom. Then we have 5, 6 at the back. 2 facing to us, 2 at the back, a total of 4. Then top and bottom. So we have a total of 6. So if A is the length of the edge, then of course we know already the volume, that is equal to a cube, and the surface area, that is equal to 6a squared. Okay, so it has 12 edges. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have here a hexahedron or a cube. Next, we have the octahedron. So an octahedron is a polyhedron with 8 equal faces, and each face is an equilateral triangle. So it has 12 edges and 6 vertices. So I have here now. So imagine that an octahedron is composed of 2 square pyramids put together base to base. So this is one square pyramid, and then we have also another square pyramid. So they were put together base to base. So we have here an octahedron. So if A is the measure of the edge, so the volume is square root of 2 over 3a cubed, and the area is 2 square root of 3a squared. Now again, for the area of the octahedron, we can just use the area of one equilateral triangle and then multiply it by 8. So we arrive with 2 square root of 3a squared. Next, we have the dodecahedron. So a dodecahedron is a polyhedron with 12 equal faces, and each face of the dodecahedron is a pentagon. So it has 30 edges and 20 vertices. So I have here the dodecahedron. So take note, each face is a regular pentagon. So if A is the length of the edge, so the volume is equal to 7.66a cubed, and the surface area is 20.65a squared. Then we have the icosahedron. So the icosahedron is a polyhedron with 20 equal faces, and each face of an icosahedron is an equilateral triangle. It has 30 edges and 12 vertices. Okay, so we have here the figure of an icosahedron. Okay, so we have here the formula for the volume and the surface area if A is the length of the edge. So take note, each face is also an equilateral triangle. Okay, so we can have representative problems. By the way, we have the relation between number of vertices, edges, and faces, no? For a regular polyhedron. Okay, so if V is represented as the number of vertices, E as the number of edges, and F as the number of faces of a polyhedron, then V plus F is equal to E plus 2. And then the number of edges is also equal to N times F over 2, where in this formula, N is the number of sides of the face. N is the number of sides of the face. So let's say if we have a triangular face, then there are three sides of the face. Then F is the number of faces of the polyhedron. So we have this formula, no? Okay. So we can have the representative problems. Number 1. One edge of a regular hexahedron is 24 centimeters long. Find the ratio of its volume to its total surface area. So hexahedron is a cube. So one edge is 24 centimeters long. So figure. So we have there. So A is equal to 24. So question, Find the ratio of its volume to its total surface area. So we will compute V over S, or V over A. A represents the surface area. So volume is A cubed, A is 6A squared, A cancels out, so V over A is equal to A over 6. And the length of the edge A is 24, so we have V over A equal to 4. Yeah. Okay, so we have here, problem. A cube has a volume of 27,000 cubic centimeter. The cube is cut by a plane containing two diagonally opposite edges of the cube. Find the area of the section thus formed in square centimeters. Okay, so we will compute the area of the section formed when you cut the cube containing the two oppositely or two diagonally opposite edges. Okay, so draw the figure. So I have here the cube, then the volume is 27,000. So I can solve for the length of the edge, x. So x cubed is equal to 27,000, so x is 30. Okay, now I will cut a section that contains two diagonally opposite edges. So I will have these two diagonally opposite edges. So when I cut it, I have this section. So that is the section with the green color. Okay. So what is the area of the section? So x is 30. I will call this length of the diagonal as y. So if I will consider the section, I will call this y. So notice that y squared is equal to x squared plus x squared. Then I can solve for y, 42.43. So the area of the section is equal to 30 times 42.43. And that is equal to 1,273 square centimeters. Okay, and then we can have next problem. The surface area of a regular tetrahedron is 173.2 square centimeters. What is its volume? Okay, so solution. I have here a regular tetrahedron and the surface area is 173.2 square centimeters. So from the formula, if you recall, area is square root of 3a squared. So surface area is square root of 3a squared, and this is 173.2. So I can solve for a, that is equal to 10. Okay, so what is the volume of the tetrahedron? So the formula for the volume, square root of 2 over 12, a cube. So volume equal to square root of 2 over 12 a cube, and I have solved a, that is equal to 10. So I can solve for the volume, 117.85 cubic centimeter. Next, I have here a polyhedron having 12 faces and has its face 12 regular pentagon is called dodecahedron. Determine the number of edges. Okay, so we have here a polyhedron having 12 faces and each face is a pentagon. So for each face, since it is a pentagon, we have 5 sides of its face. Okay, so determine the number of edges. So I have here a dodecahedron. So we have the formula. The number of edges, E, is equal to n times f over 2. Where n is equal to the number of edges of the face. So pentagon, we have 5. And the number of faces of the polyhedron, so we have 12 faces. So this is 5 times 12 over 2. And that is equal to 30 edges. Okay, so that is about regular polyhedrons. Okay. So next topic, we have here a prism. So a prism is a solid figure bounded by two equal and parallel planes, and all other faces are parallelograms. Okay, so bounded by two equal and parallel planes, and all other faces are parallelograms. So the two equal and parallel planes are called the bases, and all the parallelograms are called the lateral faces. So the intersections of the lateral faces are called the lateral edges and are parallel to each other. The perpendicular distance between the bases is the altitude of the prism. So if I will draw a prism here, so we have here the bases. Tingnan natin, Okay. So we have here the bases, and the perpendicular distance between the bases is what we call the altitude. And the altitude is represented by letter H. So these faces are called the lateral faces, and they are parallelograms. Or in this case, we have a right prism, so this is rectangles. Okay? So we have lateral faces, and the intersection of the lateral faces is an edge. So we have the base edge, the lateral face, and then we have a vertex. Okay. So the volume of the prism is equal to area of the base times the height. Then the lateral area is perimeter of the base times the height, or the sum of the areas of the parallelograms. Compute the area of each parallelogram and then add. Then the total surface area. So when you say lateral area, by the way, lateral area excludes the base. So pag kasama na yung base, lahat-lahat, we call it the total surface area. So the lateral area plus the base areas. Okay? So for example, I have here the base of a right prism is a hexagon with one edge equal to 6 cm. The volume of the prism is 500 cubic centimeter. Find the distance between the bases of the prism, number 1. Then number 2, compute the lateral area of the prism. And then number 3, compute the total surface area. Okay, so I have here solution. So I will just draw the base of the prism. Now anyway, we know already what is a prism. So I will just draw the hexagon base, and the edges are each 6 cm. So I have here the base now. Okay, so we have the edges, we have 6 cm. Now, take note that for a regular hexagon, when you divide it into triangles, each triangle here is equilateral. So you have 6, 6, 6. Because this angle is 60. Each angle here is 60. 360 divided by 6. So if we have here 60, then each here are also 60. Okay? So we can simply solve for the area, or the question number 1, find the distance between bases. The volume is given. The volume is given. So I can solve for the area of the base. So area of the base is equal to 6 times the area of the triangle here. And the area of the triangle is 1/2 6 squared sine of 60. So the area of the base is 95.53 square centimeters. Okay, then I can solve for the volume, or I can use the formula for the volume to compute the distance between the bases. By the way, the distance between bases is the altitude. So volume is 500, then area of the base, so the height is 5.35. Okay, question number 2, compute the lateral area of the prism. So the lateral area is perimeter of the base times the height. So perimeter of the base, we have 1, 2, 3, 4, 5, 6. 6 times 6, na? 6 times 6 times the height, 5.35, 192.6. And the total surface area is equal to the lateral plus the base areas. So 192.6 plus twice of 95.53. That is 379.66 square centimeters. Okay, so that is about prism, no? We have a second example. A trough whose ends are isosceles right triangles with vertical axis is 20 feet long. It contains 40 gallons of water. How deep is the water? And we have the conversion, 1 gallon equal to 231 cubic inches. Okay, solution. So, a trough is a container used for feeding animals, no? So, I have here, the ends are isosceles right triangles. So, two equal sides and meeting at an angle of 90 degrees with vertical axis. Naka-vertical tong dalawa, no? Then, the length is 20 feet. Then, it contains 40 gallons of water. Question, how deep is the water? Okay, ito. How deep is the water? So, if this is h, the top water edge here is twice of h. Why? Because if this is h, this is also h here. So, this is h at the middle. This is also h. So, this is twice of h. And the length is 20 feet. I will convert it to inches. So, 20 times 12, that is 240 inches. So, this contains 40 gallons of water. So, volume is equal to area times height or area times the length. No? Area of this cross-section with the water times the length, 240 inches. So, volume is 40 gallons. Convert it to cubic inches. No? 40 times 231 equal to area of the triangle 1/2 h times 2h times 240. So the only unknown here is the depth of the water, h is 6.20 inches. Okay, we have here a truncated prism. So when you say truncated, that means a part remaining of a prism when you cut. Na? To truncate is to cut. And so a prism with lateral edges are of an equal length. Because this is the remaining part after we cut a prism. Na? So we have a figure of a truncated prism. So we have the base and then we have here the heights. Na? H1, H2, H3, H4. Then we have the area of the base. So the volume of the truncated prism is equal to area of the base times the average of the heights. Sum of the heights divided by the number of the heights here. Then the lateral area is equal to perimeter of the base times the average of the heights. Then total surface area, so lateral area plus area of the base plus the area of this part here, the top area of the top. Okay, so we can have the problem. A truncated prism has a horizontal base ABC. AB equal to 30 cm, BC equal to 40 cm, and CA equal to 50 cm. The vertical edges through A and C are 18 and 27 centimeters long. If the volume of the prism is 13,800 cubic centimeter, determine the height of the vertical edge at B. Okay, can you imagine and draw the correct figure? So take note that the base is ABC, meaning a triangle. AB 30, BC is 40, CA is 50. So have you noticed that these three sides of the triangle at the base, AB, BC, and CA, forms a right triangle, no? 3, 4, 5. So that's 30, 40, 50 centimeter long sides. Okay? So, at A, we have 18 height. At C, we have 27 height. What is the height at B if the volume is 13,800? Okay, so I will solve. So this is now the figure. So at A, the height is 18. At B, the height is unknown h. At C, the height is 27. 30, 40, 50, right triangle. So from the volume, that is area of the base times average of the three heights. So volume is 13,800. Then area of the base, triangle, 1/2, 30 times 40. Then height 18 plus h plus 27 over 3. So from this, we can solve for the height, and that is equal to 24 centimeters. Okay, so that is truncated prism. Next problem, we have next solid, no? We have a rectangular parallelepiped. Still in prism, okay. So a rectangular parallelepiped is a rectangular prism, no? So prism with a rectangular base. So we have it here, no? So length, width, and then height. So the volume is the product length times width times height. The lateral area twice L times H, na? So front and back plus twice of 2 or W times H at the sides. The total surface area, you add the top and the bottom area, 2 times LH. Okay, so I can have a problem. Find the volume of a regular or rectangular parallelepiped. The dimensions of whose base are 14 inches and 9 inches. And with the area of its entire surface is 620 square inches. Okay, so we have here the rectangular prism. The length is 14 and the width is 9. The height is unknown, but the total surface area is 620 inches, square inches given. So we have the total surface area twice of L times H plus twice of LW, LW, top and bottom, plus twice of WH, the left side and the right side. Okay, so 620 equal to 2 times 14 times 9 plus 2 times 14 times H plus 2 times 9 times H. And we can solve for H, that is equal to 8 inches. Then the volume, that is equal to LWH, 1008 cubic inches. Okay, next we have the pyramid. So the pyramid is a solid figure bounded by 3 or more triangular faces which have a common vertex. And one other plane face is any polygon which intersects each of the triangular faces at its edges. So I have here a pyramid. So we have here. So this solid has 3 or more triangular faces which we call the lateral face or the lateral faces. And they have a common vertex. Then we have one polygon, any polygon, we call it at the base, and it intersects the triangular faces at its edges. Okay, so we have here the distance from the plane of the base to the vertex, the perpendicular distance, from the plane of the base to the vertex, we call it the altitude or height h. Then we have here the base. Then we have here the base edge. We have the lateral edge. We have the lateral face. Then we have here what we call the slant height. So the slant height is the perpendicular distance from the edge of the base to the vertex. And so we have here the slant height L. Okay, so what are the formulas that we have? For pyramid, the volume is equal to 1/3 area of the base times the height h. Then the lateral area is equal to 1/2 perimeter of the base times the slant height. Or simply add the area of the lateral faces, which are triangles. So simply solve for the areas of the triangles and then you add. So that is why we have here summation of the area of the triangles or the lateral faces. Then the total surface area, we have the lateral area plus the area of the base. Okay, so we have here the vertex. Okay, so we can have the problem. Find the volume of a regular hexagonal pyramid if the perpendicular height is 16 centimeters and the side of the base is 3 centimeters. Okay, by the way, we will just add a question for this problem. So instead of finding the volume, I will just find the volume and then I will add a question, find the lateral area, and then also find the total surface area. So regular hexagonal pyramid, the perpendicular height is 16 and the side of the base is 3. So number 1, find the volume. Okay. So I can consider the regular base, the hexagonal base. So this is a hexagon with base edge 3 cm. Then the perpendicular height is 16. So if we have the area of the base 6 times area of the equilateral triangle, if we divide the hexagon base into triangles, each triangle is equilateral with sides 3 cm. So area of the base is 23.28. So we can solve for the volume. 1/3 area of the base times the height. So that is 124.71 cubic centimeter. Okay, so for the lateral area, we will solve for the slant height. So take note that the green line here is the slant height, and this blue line is the perpendicular distance from the center to the edge of the base. So half of this is 1.5, because this is 3, so half of that is 1.5. So this is also 3 because we have a hexagon. So 60 degrees angle. So I can solve for A. So A can be solved with is sine of 60, or A is equal to 3 sine of 60. A is 2.6. And I can solve for L. So L here is equal to, or L squared is equal to h squared plus A squared. So 16 squared plus 2.6 squared, 16.21 centimeters. So I can solve for the lateral area. 1/2 perimeter of the base times the slant height. So 1/2 perimeter of the base 6 times 3 and slant height 16.21. So the answer is 145.89 square centimeters. Then the total surface area, the lateral plus the base area. Okay, so lateral plus base area 169.17 square centimeters. Okay, we have the solid which we call the frostum of a pyramid. So frostum is the part remaining when you cut the pyramid containing the vertex. So the remaining part is this, na? So we call it the frostum of a pyramid. So we have now two bases which are similar polygons, na? So h, the perpendicular distance between the bases. So lower base A2, upper base A1. Then we have the lateral face. And we have here the slant height L. So formulas, volume equal to h over 3 area 1 plus area 2 plus square root of area 1 times area 2. Then the lateral area is summation of the areas of the faces. Now take note that the area of the faces are trapezoids. So for frostum with regular base, area of the lateral surface is 1/2 P1 plus P2 times L. Or simply, solve for the area of each trapezoid and then add up. So total surface area, so of course, total surface area, that is the lateral area plus the area of the bases. Okay, so for example, we have here a rectangular block of alloy has the following dimensions: 4.3 centimeters by 7.2 centimeters by 12.4 centimeters. It was melted and recast into a frostum of a square pyramid, 10% of the metal being lost in the process. If the ends of the frostum are square, 3 centimeters and 8 centimeters respectively, determine the height of the frostum. Then number 2, compute the total surface area of the frostum. Okay, so this is combination of shapes, no? So una, we have a rectangular prism, the dimension 4.3 by 7.2 by 12.4. And this is melted to recast into another solid, which is a frostum of a square pyramid. But take note, during the process, there is 10% of metal lost. Okay, so solution. So considering the rectangular block, we have 4.3, 7.2, and 12.4. So the volume, L times W times H. So 12.4 times 7.2 times 4.3, that is 383.9. Then we can consider the frostum of the square pyramid. So the ends of the frostum are square, 3 by 3 cm and 8 cm. So at the top we have 3 by 3. At the bottom we have 8 by 8. So area 1 is 3 squared 9. Area 2 is 8 squared equal to 64. Question number 2 or number 1, determine the height of the frostum. The edge. So the volume of the frostum, I will call it V2, is 90% of V1 because 10% will be lost during the process. So 0.9 of 383.904, so 345.51. So for the formula for the frostum, h over 2, area 1 plus area 2, square root of area 1 times area 2. We have already area 1 and area 2. Then volume V1. Volume V2, we have already that. So substitute, we have this, and the only unknown for this equation is h. So we can solve for the height of the frostum, 10.69 centimeters. Then number 2, compute for the lateral area of the frostum, or lateral area or total surface area. Total surface area of the frostum. Okay, so I will need the slant height. This na. Okay, so if this is 3 and this is 8, so the difference between 3 and 8 is 5, and then half of that is 2.5. So this is 8, the blue line, the height. Then this is 2.5, the red line. Excluding this. Then we have here the slant height L. So we can compute for the slant height L. So 10.29 h na. So 10.29 square plus 2.5 square. So that is 10.59. Okay. So for the lateral area of the frostum, 1/2 12 perimeter na 3 times 4 plus 4 times 8 32. And slant height 10.59 232.98. So the total surface area 1 9 plus area 2 64 plus area of the lateral surface 232.98. So we have 305.98 square centimeters. Okay, so we have the next topic, the next solid, cylinder. So a cylinder is a solid bounded by a cylindrical surface and two parallel areas at each end. So the parallel areas are called the base and the bounding cylindrical surface is called the lateral surface. Perpendicular distance between the bases is called the height or the altitude of the cylinder. So I will have here a right circular cylinder, no? So this is what we call the cylindrical surface, that is the curved surface area. Then we have here the bases which are circles, no? So these are the two parallel bases or parallel surfaces. Okay, so the distance between them is the height or the altitude. Then we have here the radius r of the circular base. Okay, so what are the formulas that we can apply? Volume equal to pi r squared h or 1/4 pi d squared h. By the way, the formula for volume and surface area of cylinder and prism are just the same. Huh? Actually, cylinder can be termed also as prism and prism can be termed also as a cylinder. But only that when you say cylinder, you may think that the base is a curved circle. Huh? But prism, you may think that the solid, the base is a polygon with straight edges. But the two means the same. Huh? Okay. So volume equal to pi r squared h. So area of the base times height. Huh? So area of the base 1/4 pi d squared times height. Lateral area, we have here perimeter of the base times height. But in a circle, the perimeter is the circumference 2 pi r, then times h, or pi d times h. Total surface area, if in case we have the top and bottom are closed, so total surface area, 2 area of the base plus the lateral area. Okay, so we can have problem, no? So problem 1. 49.48 square meters of sheet metal was used to construct a cylindrical tank with an open top. The height of the tank is 1.5 times its diameter. Find the radius of the tank. Okay, so drawing, we have a cylindrical tank. Okay, so cylindrical tank. The height h and the radius of the base r. So take note that the height is 1.5 times its diameter. So if the radius of the base is r, so the diameter is 2r. So the height is 1.5 of the diameter 2r, so that is equal to 3r. Okay, then the total material needed or the total material to make the tank is 49.48 square meters of sheet metal. Then open top, so do not forget we have an open top. So we have only one area of the base because the top is open. Okay, so the lateral or the total surface area A is equal to area of the base pi r squared. Now take note, not times 2, because the top is open. plus the lateral area 2 pi RS. Excuse me. Okay? So the total surface area is 49.48 equal to pi r squared plus 2 pi r times h, which is 3r. So the only unknown here is r. Then you can solve for r, that is 1.5 meters. Next problem we have here. A swimming pool is rectangular in shape of length 12 meters and width 5.5 meters. It has a sloping bottom and is 1 meter deep at one end and 3.6 meter deep at the other end. The water from a full cylindrical reservoir 3.6 meters in diameter and 10 meter deep is emptied to the pool. Find the depth of water at the deep end. Okay, so there is a swimming pool with a given dimension and shape, and then the water to be placed there comes from the water of a full cylindrical reservoir 3.6 meter in diameter and 10 meter deep. So find the depth of the water of the pool at the deep end. Okay, so we will start with the swimming pool. We will start with the cylindrical reservoir. No? So from the reservoir, the diameter is 3.6 and the depth is 10 meters. So volume is equal to pi d squared over 4 times the height. So pi d squared over 4 times the height. So that is 101.788 cubic meter. Okay, now, if you consider the swimming pool, the shape is like this, no? The length is 12 meters, the width is 5.5. At one end, it is 1 meter deep, and the other end, that is 3.6 meter deep. So meaning there is a difference of 2.6 meters between the edges, na? The two edges. So that is why we have a sloping base here. Okay. So let us say the water extended up to this height, na? The height that is at a distance of x from the bottom of the 1 meter deep. Okay, so a height of x meters now from this point here. Okay, so I will call the volume of water at the bottom here V1 and the volume of water somewhere here V2, now with the depth x. Okay, so V1 I can solve it because this is in terms, or this is in the form of a prism with the area of the base, a triangle, and the length or height is 5.5. So V1 is 1/2, 2.6 times 12 times 5.5. Na? So area of triangle, 1/2, 2.6 times 12 times the length or height, 5.5. So V1 is 85.8 cubic meter. Okay? And then I can solve for V2 in terms of x. So this is a rectangular prism 5.5 by 12 and the depth is x. So V2 is x times 12 times 5.5. So V2 is 66x. Okay? Okay. So take note that this water comes from this volume of water from the cylindrical reservoir. So meaning, if we add volume 1 and volume 2 here, that should be equal to our V. So, here, V equal to V1 plus V2. So, 101.788 equal to 85.8 plus 66x. And x is 0.242 meter. So, if you notice, the depth of water in the deep end is 2.6 plus x. So the question is the depth of water in the deep end. Okay, so the water there is 2.6 plus 0.242. So that is equal to 2.842 meters. Next, we have the cone. So the cone is defined as, or a conical surface is a surface generated by moving an oblique line about an axis, intersecting it at one end and tracing a fixed curve on a plane, intersecting it on the other end. Okay, like this. So this is a line, and then we draw an oblique or a slanting line intersecting this. Now notice that when you revolve this about the line, then you can trace here a circle at the base. So let us revolve. So when you revolve, this will trace also a surface. The surface traced by this red line is what we call a conical surface. And this red line is what we call the generator. Then this top here is what we call the vertex or the apex. This is, or the trace here is what we call the directrix. So, a solid bounded by a conical, a solid bounded by a conical surface. By the way, ibalik muna natin to. Ito yung vertex, ito yung axis, generator, and then directrix. Okay? Kuha, no? Okay. So, a solid bounded by a conical surface and with a circular base is what we call a right circular cone. So, axis, we have the vertex or apex, the altitude or height, then we have here the radius of the base r. Okay, so we have here the lateral surface. So what are the formulas that we can apply? By the way, we call it slant height na L. Hindi ko na lang nalagyan. Mayroon pala, slant height L here. Okay. So volume equal to 1/3 pi r squared h. By the way, the formula for the cone and the pyramid are also the same. So notice, the volume of the pyramid is 1/3 area of the base times height. Here, 1/3 pi r squared h, because the area of the circular base here is pi r squared. Or that is 1/12 pi d squared h. Area, lateral area, pi rl, or pi dl over 2. Then total surface area, area of the base plus the lateral surface. Okay, so problem. The lateral area of a right circular cone is 634 square meters. If its diameter is 2/3 its altitude, determine its altitude in meters. Okay? So we are given a right circular cone and the lateral area is given. Diameter is 2/3 the altitude. So determine the altitude. Yes. Version. We have that, So the height, then we have here the radius. The diameter is 2/3 of the height. Okay? So lateral area, we have pi rl. So this is equal to 634 pi rl. So we can divide by pi. So rl is 201.81. Also in the figure, we can use Pythagorean theorem. By the way, d is 2/3 of the height. So if d is 2/3 of the height and d is equal to 2r, twice of the radius, so the height is 3 times r. So if we can solve for r, multiply it by 3, then we can solve the requirement, the altitude of the cone. So from Pythagorean theorem, L squared is equal to h squared plus r squared. But h is equal to 3r, then plus r squared. So we can express L in terms of r. Then we can have RL equal to 201.81, but L is r square root of 10. So R and L is r square root of 10 equal to 7.99. So R is 7.99. Then the altitude h is equal to 3 times r. Approximately, that is 24 meters. Okay. Next, we have here a sector is bent to form a cone. If the angle of the sector is 60 degrees with a radius of 6 centimeters, what would be the radius of the cone if it has a slant height of 6 centimeters? Okay, so can you imagine how can we form the cone? No? So the cone is formed from a sector with central angle 60 degrees and radius of 6 cm. So what is the radius of the cone if the slant height is 6 cm? Okay. So we are here. So this is the sector. Then how will we form this into a cone? So we will let the two radii here intersect. Also these 2 points intersect here, so that we can form a cone. So this will be rolled so that this will coincide with this radius also. Then we can form the cone here. Okay. So the question is the radius of the base. So the slant height is also 6. Of course, no, because this is the radius of the sector 6. Radius of the sector, which is 6 centimeters. That is also equal to the slant height of the cone. So notice that this circle here at the base of the cone is also the same length as the arc of the sector here. Can you follow? You will roll this. So meaning this becomes the circular base of the cone. So we can equate circumference equal to the length of the arc. Okay? So S, length of the arc, equal to the circumference of the base of the circle. So length of the arc, r theta, 6 times 60, convert to radian, pi over 180. Circumference, 2 pi r. So pi cancels out, we can solve for r, that is equal to 1 cm, which is the question. So find the radius of the cone, 1 cm. Okay, problem 3. A grain elevator hopper is to be constructed with a circular cylinder of radius 2 feet and altitude of h feet on top of right circular cone, whose altitude is 1/2 that of the cylinder. Question: what value of h will make the total volume of the hopper equal to 500 cubic feet? Okay, so can you imagine the form of the green elevator hopper? A circular cylinder on top of a right circular cone. The radius is 2 feet, the height h of the circular cylinder, while the height of the cone is 1/2 that of the cylinder. So if this is h, the height of the cone is 1/2 of h. Okay? Then the question, what value of h will make the volume equal to 500 cubic feet? Okay? So we can draw the figure. So this is the cylindrical part and this is the conical part. The radius is 2 feet. Then the height here is h. And the height here is 1/2 of h. The same radius of the base here. Okay. So the volume is just a combination of the cylinder and the cone. So volume is equal to volume of the cylinder plus volume of the cone. So we have volume equal to pi r squared h plus 1/3 pi r squared height. Okay. So the radius is 2, the height of the cylinder is h, For the cone, the radius is 2. The height of the cone is h/2. And the volume is 500 cubic foot or cubic feet. So, the only unknown here is the height, that is equal to 34.1 foot or feet. Okay, so next we have here a frustum of a cone. So a frustum of a cone is a part remaining of the cone when you cut the cone and taking out the part there containing the vertex. So the formula for the frustum of the cone is the same as the formula for the frustum of the pyramid. So we have here radius of the lower base, big R, radius of the upper base, smaller r, and the distance between the bases. The perpendicular distance between the bases is the height or altitude of the frustum of the cone. So we have the slant height here, L. Okay. So volume is equal to h/3 area 1 plus area 2 plus square root of area 1 times area 2. Or in terms of the radius of the bases r, we have this formula. Then the lateral area in terms of the circumference of the bases C1 and C2, or in terms of the radius R. Then total surface area, area 1 plus area 2 plus area of the lateral surface. Okay, so we can have a problem here. Determine the volume of a frustum of a cone if the diameters of the ends are 6 cm and 4 cm and its perpendicular height is 3.6 centimeters. I think this is direct substitution to the formula, no? So we can have the radius r, small r equal to 2, no? Radius 6 and 4, so radius 2 and 3. The height is 3.6. Okay, so we have here big R, small r, and the h with the given values here. So formula, h/3 times area 1 plus area 2, square root of area 1 times area 2, or in terms of the radius, pi h/3, r plus r plus r times r. Okay, so substituting values, we have the volume 72.62 cubic centimeter. Okay, and next problem we have here. A loudspeaker diaphragm is in the form of a frustum of a cone. So the end diameters measure 28 centimeter and 6 centimeters. And the vertical distance of the ends is 30 centimeters. The curved surface of the speaker is made of felt composite material. Calculate the area of the felt composite material needed to cover the curved surface. Okay, so a loudspeaker diaphragm is in the form of a frustum of the cones. We can draw it here, no? Okay, so this is the speaker diaphragm. So we have the diameters 28 and 6, so we have the radii 3 and 14. Then the perpendicular distance, the altitude is 30. So perpendicular distance between the bases or the ends. So small r is 3, big R is 14, height is 30. So calculate the area of the felt composite material needed to cover the curved surface. So this is the surface area, no? So the material needed, the amount of material needed correspond to the curved surface area or the lateral area of this frustum here. Okay. So the height is 30. So this is 30 here, no? Then the difference between 14 and 3 is 11. So this is 11 here. Then we have here the slant height L. So to compute for L, so L squared is equal to 30 squared plus 11 squared, and that is equal to 31.95 centimeters. Okay, so the lateral area of the frostum, that is pi r plus r times L. So r is 3, big R is 14, L is computed 31.25. So the lateral area or the total material needed is 1,706.4 square centimeters. Okay, so this ends our discussion here. So we have covered already the plane geometry and then the solid geometry now. So I think we still have more solids next meeting for geometry. Then we will go to spherical trigonometry. No? Okay. So I think we have many topics discussed already. We have many formulas already discussed. So kindly recall them. No? Recall them and then time to time memorize so that during the actual or during the quizzes and also in the actual board exam, you have memorized already the necessary or the needed formulas, no, in case they will come out in the board exam. Okay, so thank you very much for listening, for viewing my video, and then stay safe everyone at home, and God bless.